Now next, I2, I3. So from root node, I2 is there, so the value will be updated to 5. And is there any node that is I3? Yes, there is one node that is I3. Oh, the old value was 1, now it is updated to 2. Next time, I1, I3. Now from root node I1, yes, it is there, and from I1 it is there, I3 is there. So we will just update the value because the path is already there. Next time, now I2, I1, I3, I5. So from root node, we are traversing to I2. So it will be updated as 6. And from I2, we have to go to I1. So I1 will be updated as 3. And from I1, we have to go to I3. So I3 is not there. That means there will be new node generation because from I1, we don't have any path as I3. So we'll have to create a node which is I3, and from I3, there will be a new node that is I5. And then we will update the value of I3 because it is observed once from this path, so it is 1, and then I5 is 1. And then last transaction, that is I2, I1, I3. So I2 is again here, so we'll update the value of I2 as 7. Then from I2 we are going to I1, so the value will be updated as I4, and from I1 we are going to I3, which is this node, the value will be updated as to 2. And then the ordered list is over. Now this is the FP tree, and these are the values that for every transaction the values are getting updated starting with 1, and the as the nodes are added to the list or added to the FP tree, the count is updated. So as you can see, the final value of that node will be considered, the final updated value will be considered as the final value for that particular item. So for example, I2, the frequency of I2 is 7. Similarly, I1, the frequency of I1 is 4. Similarly here, frequency of I1 is 2 because last updated value is 2. And if you want to cross check this, if your FP tree is right or wrong, you have to cross check this value with the occurrence of your item or the support count of the item. So this image is created for your understanding, but now let's see, I'll just delete this part. So if you see, this is the final root, right? So this is my null root, and these are the nodes that we have created with their final support count value or the frequency values. And if you try to draw it on the book, this will look like this. But what you have to do is, you have to create a table with items and their support counts, and there will be one node link which you have to point to all the occurrences of that item in your FP tree. For example, I2. So if I'm talking about I2, the total support count is I2. So where I2 node can be seen, so there is only one location where I2 is there, so you will point this to I2 with a dotted line. Similarly, now if you go and check for I1, now I1 is 6, so you have to find those nodes where I1 is given. So here I1 and here I1, right? So in your tree, if you see, I1 is here and I1 is here. So you have to point to these two nodes with a dotted line. And if you cross verify whether the FP tree is right or wrong, you can just cross check with the count. So if you see I2 is 7, so here the only single node is there I2, and which is having the total count as 7. Similarly, I1 is 6, so I1 4 plus I1 2, that is 6, so total 6. And similarly, you can give all the links to the items present in your FP tree. So this is how your final tree looks like. Now once we have final tree, now what we can do is, now we can go ahead with the next stage, which calculates the conditional base patterns. So how to do that? So mining the FP tree by creating conditional pattern bases. So we will be taking the same FP tree now, and we will be creating a pattern. So how to create a pattern? So we will always start with the minimum support count now. So opposite of what we did in the first stage where we took the high support count, now we'll start with the minimum support count. So I5 has a minimum support count, that is 2. Now the conditional pattern base is where you have to find out that from which nodes you can reach to I5. So if you see in your tree, there are two nodes, I5 with value 1, I5 with value 1, and if you try to traverse to this node, you can come from this to this node by I2 and I7. So one link is I2 to I1 to I5 and one is I2 to I1 to I3 to I5. So you have to write down from which node you can traverse to I5. So I2 to I1 with the value of I5 as 1 and I2 to I1 to I3 with the value of 1. So you are just writing the count of I5, that is in this path it is observed once and in this path it is observed once. And similarly you will calculate for the next support count, that is 2. So I4 that is I4. So again you will take I4 and you will see I4 is traversed from which node. So I2 to I4 to I2 to I1 to I4 with support count 1 and then that only from I2 with support count 1. So you have written I2 to I1 with support count 1 and I2 to I2 to I4 with support count 1. So you don't have to include the node itself. You just have to write down through which points you are traversing to that node, right? And the total with what support count you are traversing. So you will be going ahead with I3 and I1. Why we are not including I2 here? Because if you see I2, okay, I'll go to that part later. First, we will see I3 now. So I3 is again I3, one is here and one is here. Now you have to always separate the left tree and right tree. So if you see I3 can be reached from say I2, I1 with 2 count and I2 with 2 count. So that is one I2 to I1 with 2 count and I2 with 2 count. And then one more is there, that is I1 to I3, that is from I1 with the count 2. So from I1 with the count 2. And this, after you write this, what we will do is we will go ahead with I1. So now I1 is direct, there is only one node, this is I1, and there is one node I1 in the right subtree. So we'll be writing this I1 because it is reached from I2, but you will not write for this because it is directly reached from the root node. So there is no intermediate node that is there to reach I1. So you just have to write the intermediate nodes. So there will be only one I2, I4. And once you have this, what you'll do, we'll write the conditional FP tree. How? So you just have to add the counts. So here I2 is 1 and here I2 is 1. That means the total count is I2 2. Similarly, I1 is 1 and I1 is 1. So total count is 2. And here I3 is 0 and I3 is 1. So total count is 1. But for this problem, we are assuming that the minimum support is 2. So same problem that we have seen using a priori. So the minimum support is 2. Therefore, we will skip I3 here. Again, for this purpose, you will write I2 is 2, I1 will be skipped because its support count is low than the minimum support. Now, in this problem, we will separate the left subtree value and right subtree value. So, this right subtree value I1 will not get merged with the I1 value of your left subtree. So, left subtree values will be added and right subtree values will be added separately. And then, this is only a single value, so it is written. Now you need to generate the frequent pattern. So what you have to do, you just simply have to create the rules with these conditional FP tree values. So I5 to I2, I5 to I1. So in this way. So what you're writing, I2 to I5 with support count 2. Similarly, I1 to I5 with support count 2. And then I1, I2, I5 with support count 2. Similarly, here also I2 to I4 with support count 2. Then here I2 to I3 with support count 4, I1 to I3 with support count 4, then I1 to I3 with support count 2 in this way. And then the merging of means all the possible combinations of these values and then I1 to I2 in this way. And these are nothing but your frequent pattern generated from these conditional pattern bases. So as you can see, these are the same that we have got from a priori algorithm at the end, and then later on you can apply the confidence value to check which are the strong rules and which are the weak rules, and then these will be the final answers. So this is how we solve the frequent pattern using FP tree.